This video will be covering the topic calculus, which is a very important topic in Math AHL since it can be seen in other topics, for example, like functions. So the main parts of calculus are going to be differentiation and integration. The first example that we're going to look at is integration using the integration by parts. So this formula can be found in the formula booklet, and it goes like this. The integral of u multiplied by dv over dx equals uv minus the integral of v du dx. So what this is saying is, if you have the integral of two things multiplying each other, you're going to have to say that one of them is u and one of them is the derivative of v. So an example of this can be x ln x. So here we have we would have to see one of them is x and one of them is ln x. So to decide on which one is going to be u and which one is dv over dx, we have to look at which one is easier to differentiate. For example, whichever variable we put as u, we're going to have to do the derivative to get d over dx. And then whichever one we pick to be dv over dx, we're going to have to do the integral of it to get v. Since the integral of ln x is just, it's more complicated, so it'll just make you do more work, we can set ln x as u because the derivative is known because it's in the formula booklet. It's 1 over x. And then if we put x as dv over dx, the integral is also quite easy. It's just going to be x squared over 2. Now that we have all these variables, we just have to plug them into the equation. So that would be u, which is ln x, times v, which is x squared over 2, minus the integral of v, which is x squared over 2, multiplied by 1 over x dx. So we can simplify this by saying x squared ln x over 2 minus the integral of x over 2 dx. Yep. And now, if we just let's take this part away. Now we can do the integral, which is quite basic as well. So here, this equals x squared over 2, and then divided by 2 again, which equals x squared over 4. And then finally, if we rewrite everything again, it will give us a final answer of 1/2 x squared ln x minus x squared over 4. And don't forget to put plus c. So this is the final answer for the integral of x ln x using the integration by parts method. So now, the next part we will look at is the product and quotient rule, which are quite similar. They work in the same way. So let's just look at the product rule. This formula is also in the formula booklet, so it is often quite easy to understand. So the formula in the formula booklet goes like this for the product rule. U derivative of v derivative of x here plus v derivative of u, like this. So once again here, we're going to have the differentiation of two things multiplying each other, and we'll set one of them as u and one of them as v. This is different from integration by parts because we're not setting any of them as the derivative of v or u. So for example, if you have an example like cosine x squared, make it a bit harder. So we can set u as cosine x and then v as x squared. Then we have the derivative of u is going to be negative sine x, and then dv over dx is going to be 2x using the power rule for x squared. And now we plug this into the equation above. We're going to get cosine x times 2x plus x squared times negative sine x. Now if we simplify this, we get 2x cos x plus, actually no, minus x squared sine x. And that is our final answer. And for the quotient rule, you do the exact same steps, except that the quotient rule is just a different formula, which is also in the formula booklet. And it goes like this. We have v du over dx minus u dv over dx over v squared. So the same thing here, you just have the differentiation of two things dividing each other, and you'll set one as v, one as u, and then you just plug it in this formula, and then you get your final answer. So that is the overall of the basic parts you need to know of calculus that are very important, because every other part of calculus is going to use differentiation or integration, and also many parts of functions, for example, like finding the maximum of a function, you're going to have to know derivatives, etc. So as long as you know how to do integration and differentiation, it will be very helpful for you for other parts in calculus and also functions. Thank you for watching the video on calculus.